This week on the show, we explain the physics behind ZFS a little bit. We also covered DTrace switching to the GPL, Emacs debugging. We cover syncookies coming to PF, and take a look at FreeBSD's history on EC2 in this week's episode on BSD Now. BSD Now, episode 233, High on ZFS, recorded on the 14th of February 2018, Valentine's Day. I'm Benedikt Reuschling, your co-host.
And I'm Alan Jude.
And it's not just Valentine's Day, but we also have a great show prepared for you, as always, this week, starting off with our headlines. And we dug out a little bit of an older piece this time. 128-bit storage. Are you high? So what's this all about?
Yes. So if you've ever heard the quote about ZFS being such a large file system that if you actually had enough hard drives to reach the maximum size that ZFS can do in a single file system, it would take so much electricity to power those drives that would boil all the water in all the oceans on Earth. But we wondered where'd that stat come from or whatever. And we found somehow rescued on the old from the old Sun website onto Oracle's site is this rebuttal to a response, or one of the comments on one of the original articles about ZFS that went up on sun.com. So you have to remember, this is from 2004 when people didn't know what ZFS was, and it wasn't open source yet until the next year. But this is a blog post by Jeff Bonwick, who's the other co-creator of ZFS, the original guy, who basically mentored Matt Aarons, and they together built the file system. So we get to the question, 64 bits, that would have been plenty. We don't need to, talk out of our ass about boiling the oceans, right? So somebody commented on the original article that, why do we have to go this far? And then we have Jeff's response. He says, well, it's a fair question. Why did we make ZFS a 128-bit storage system? What on earth made us think it's necessary? And how do we know it's sufficient? So let's start with an easy one. How do we know it was necessary? So at the time, I think 2004, Sun already had some customers with data sets on the order of a petabyte. That was a lot back then. Now it's not unfathomable. I have about a petabyte if you add all of my storage servers together. So a petabyte is 2 to the power of 50, so 50 bits worth. Thus, a 64-bit capacity limit of 2 to the power of 64 is only 14 doublings away from a petabyte.
And that was 14 years ago. So,
yeah. And Moore's law for storage products predicts that the storage will continue to double every 9 to 12 months. So even if we think years, then, in 2004, they were only 14 years away from needing a 64-bit file system. So I don't know that there's that many people that need a 64-bit file system quite yet, but we're getting a lot closer to that point. So storage systems tend to live for several decades, so it would be foolish to create a new one without anticipating the need that surely would arise with these projected lifetimes. If 64 bits isn't going to be enough, the next logical step is 128 bits. That's enough to survive Moore's law until long after I'm dead, and after that, it's not my problem. But it does raise the question, what are the theoretical limits to storage capacity? Although we'd like Moore's law to continue forever, quantum mechanics imposes some fundamental limits on the computational rate and information capacity of any physical device. In particular, it has been shown that 1 kilogram of matter confined to 1 liter of space will perform at most 10 to the power of 51 operations per second. So 10 to the power of 51 would be a 1 with 51 zeros after it. That's a lot of zeros.
Yeah, but we're just getting started on that. Yeah, so the amount of information you could store on that is 10 to the power of 31 bits of information.
Right. And it's cited with the paper where that came from. So a fully populated 128-bit storage pool would contain 2 to the power of 128 blocks, which would actually be 2 to the power of 137 bytes. Because the 128-bit limit in ZFS is blocks, not bytes. And since I think technically the A shift could be as high as 8 kilobytes. So the numbers could get even bigger, actually. But yes, that's 2 to the power of 120 or 140 bits. And therefore, the minimum mass required to hold all the bits for a ZFS pool would be 136 billion kilograms. And that assumes like perfect efficiency and the best thing you can get. And hard drives are not that.
Not yet, yeah, so.
Yes, and to operate at the 10 to the power of 31 bits per kilogram limit, however, the entire mass of the computer must be in the form of pure energy. The rest energy for 136 billion kilograms is 1.2 times 10 to the power of 28 joules. The mass of the oceans is only about 1.4 times 10 to the 21 kilograms. So it takes about 4,000 joules to raise the temperature of 1 kilogram of water by 1 degree Celsius, thus 400,000 joules to heat 1 kilogram of water from freezing to boiling. The latent heat of vaporization adds another 2 million joules per kilogram. Thus, the energy required to boil the ocean is about 3.4 times 10 to the 27th joules, which is basically an order of magnitude less than the amount of power it would take to do the ZFS pool.
Okay.
So he backs it up with actual research from the Nature journal.
Yeah, for people who want to just do the recalculation and figure out all the numbers that are
follow
correct.
The citations and so on. But yes, the idea with ZFS is that you want a file system that you're not going to have to transition to or off of in a couple of years. You have to remember, back in 2004, people have had to change file systems a couple times already. Even if you're on Windows, you went from FAT16 to FAT32 to NTFS. And even with FAT32, you were still limited to having any individual file over 2 or 4 gigabytes. Back then, ext2 on Linux also had the limit. You couldn't have what were called large files, where any one file could be 2 gigabytes at most.
Ooh.
The number of files I have now that are over 2 gigabytes is just staggering.
Yeah, and I mean, many of the databases limit the number of storage they can, or stuff they can store in the database by the file system. And if the file system is exorbitantly big, then as long as you can provide enough storage space in the pool, then that shouldn't be a limit.
Yeah, so the idea with ZFS was to avoid needing these constant conversions every 5 or 10 or 15 years to a newer file system that could support the capacity you're going to need. So 64 bits wasn't going to be enough because it looked like within 15 or 20 years, it was not going to be enough. And, we've seen that. In FreeBSD, we've recently had to switch to using from 32 bits to 64 bits for inodes so that you could actually have more than 4 billion files on your one drive or file system.
And that was a huge project with a lot of people working on that for years.
Mm-hmm. Because it changed so many things and so many assumptions were made. And so ZFS wanted to avoid that problem by not making any assumptions that some arbitrarily smaller size is going to be enough. And so everything's 128-bit, basically. There are some things that are 64-bit limits, but I don't think you're going to have more than 2 to the power of 64 hard drives.
Yeah, unlikely. As long as there's a migration path from one storage medium to the next, then I'm fine.
And if you do manage to run into the 128-bit limit in ZFS someday without boiling all the oceans, you actually have support for more than one pool at a time. So you could just have two pools side by side, and now you have 129 bits of storage.
Yeah, it's crazy to think about these numbers, but yeah, it certainly adds a little bit more realism to the whole ZFS capacity. But we have more. Also a little bit Oracle related, more or less, in our next
so
headline.
Now we talked about the past and how Oracle took that over, but now we have interesting news from today.
Yeah. Well, interesting is an interesting word to use in this context, because there is news from Oracle relicensing DTrace. DTrace for Linux,
Oracle has given a Valentine to the Linux community and has relicensed DTrace as included in Oracle's Unbreakable Linux or whatever it's called. It's been relicensed, so instead of CDDL, the kernel side is GPL v2 as required to be upstreamed in the mainline kernel, and the userland parts are under the new UPL, the Universal Permissive License, which isn't exactly like a BSD license, but it's very permissive and looks interesting.
Mm-hmm.
But yes, it says this change set integrates DTrace module source directly into the main kernel source tree under the GPL v2 license. Sources have been moved to the appropriate locations in the kernel tree.
Yeah, that is right. DTrace dropped the CDDL and switched to the GPL. We give you 5 seconds for a face bomb.
Oracle's version of DTrace.
Right. Yeah, that's important to remember.
Yes, so FreeBSD still uses the version of DTrace from Illumos, which has now been collaborated into the OpenDTrace project, which integrates changes to make the DTrace work the same on FreeBSD, Illumos, OS X, and somewhat the Linux port, although that isn't the Oracle Linux port, which is different. So apparently the Oracle one has a bunch of other changes and stuff, and the kernel side stuff, because GPL v2 probably won't go back and forth with BSD, but some of the userland improvements and interface changes that are licensed under the UPL, it might be possible to pull those in or to build out similar features or interfaces to try to make the two DTraces work better together.
Mm-hmm. That would certainly be good.
But yes, so interesting. I wasn't expecting Oracle to do this. When people had asked about them doing something like this to ZFS, I figured it was pretty much just never going to happen. But seeing them do this with DTrace and CDL to GPL and UPL is interesting. Although, if they did it with ZFS, it would be quite complicated because, again, where would they draw the line on what's under the GPL and what's under the UPL? And the other question there is, again, OpenZFS is a different project, right? It was forked off many years ago now. And OpenZFS is more than 50% new code that has been added or changed since the fork. So even if Oracle did relicense ZFS, even if it was all under a permissive license instead of partly under the GPL, it wouldn't necessarily change the license on OpenZFS, because all of the people who've contributed to OpenZFS would have to agree to change their copyright from CDDL to the other one.
Oh, yeah. And I mean, with DTrace, it's different because you don't have to have pools to migrate from one system to the other. In DTrace, it's mostly scripts,
but at the same time,
those could also use different syntax
like my
over time.
DTrace script to work the same on both systems and so on.
And they might also diverge at some point where DTrace develops in one, like the Open DTrace has features that are not supported in the GPL DTrace or vice versa. So this is still...
I don't think the Oracle DTrace supports JSON output, whereas the Open DTrace does.
Yeah, and so small things like that, and people who use DTrace and come to rely on that might miss these features in one of the other systems that doesn't have that. And
very confusing when you have two different things, especially when they're called basically the same thing, and then they're not really the same anymore. And it's kind of the problem with Oracle shutting down the open bits of it and then maybe later opening them back up, is you end up with this after the fork, and then you have to try to bring them back together or something.
Yeah.
And because DTrace is really from Illumos, we can't just rename it BSD Trace.
Well, it certainly would sound nice, but it's a different heritage and where that's coming from.
So it'll be interesting to see what happens from this. But it's definitely not going to poison DTrace such that FreeBSD can't have it anymore, because we would still use the version from Illumos. Pretty much all of the original maintainers of DTrace are on the Illumos side, not on the Oracle side.
Yeah, and that's why you keep these good relationships to other people and to other projects to get these innovations and collaborate on these things.
Yes, I've been following up on my collaborations at FOSDEM with, I think it's the author of the OmniOS installer, or one of the maintainers anyway, working forward to porting some of the workarounds we have in the FreeBSD installer to work on some of the Lenovo laptops into their installer. But they've taken it further because of the way ZFS is integrated in Illumos. When a disk fails, they need to be able to apply that fix as part of like zpool replace. Which is, that whole concept is something I would like to bring into FreeBSD myself. But they're taking the installer hacks from just a couple of hacks basically and putting it into a database of the hardware and a library and making it such that it can be detected at runtime, and ZFS will know, hey, this laptop is this type, and when I replace the disk, I need to apply this change to the partition table so that the Lenovo BIOS will still boot off this drive.
Yeah, so that's the compatibility there.
Yeah, but it'd be interesting. It's like, so we have a fix in FreeBSD, and they've adopted that in Illumos, but now they're extending it, making it better, and then we'll probably pull that back down into FreeBSD.
Oh, excellent. See, this is not just a one-way street. There's
exactly
code coming back and forth. So that's certainly good to see.
This week's episode of BSD Now is brought to you by DigitalOcean. Head over to digitalocean.com and check them out. Within less than a minute, you can spin up a droplet, which is what they call their little VMs, or big VMs, depending on whatever size you want. Whether you want just one CPU or if you need 32, or, if you need a little bit of SSD storage, or if you want 4 terabytes of SSD storage.
Yeah. Or if you start small and you're going to a lot of conferences or are in hotel rooms that have not secure Wi-Fi, you can set up your little droplet at home before you travel, then tunnel all your traffic over that droplet and making sure that no one else can read your traffic while you're surfing or browsing in your hotel room or at the conference.
The droplets include a very generous amount of bandwidth. Even the $10 a month one includes 2 terabytes of transfer. They make great VPNs. They make great IRC bouncers. I finally converted Benedict to Quassel so I can leave him messages when he's not on IRC.
And you're not the only one who's leaving messages, so there's constantly blinking and beeping. But if you want to run a blog or something else, it's all available, and some of these have already been pre-configured, so you just have to select what kind of software you want to run in your droplet. They spin up the droplet for you, and you just have to make a couple of changes for security reasons, and like naming your blog or configuring it the way you like, and that's your blog experience then on DigitalOcean.
Yeah, so you have your choice of getting the bare VM and doing it yourself, which is a great way to learn BSD if you want a reasonably fast BSD computer but don't have a spare computer at home or whatever. Or you can use their instant applications type setup and just be like, I need a blog. just click, 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 and it sets it up. Or I want this software, a couple of clicks, and it deploys the OS with that software already set up for you.
And if you have a little bit more needs, like special firewalling rules, or want to add a couple of friends who also should blog on your little blog experience, then you can also set up a team so that people can maybe help you a little bit administer that system, but they cannot see the billing information.
Yep. They also have floating IPs to move a public IP address between different droplets to handle failover or migrations and upgrades, load balancers to handle if you need more than one droplet to power your workload, or because of the hourly billing, you can have one droplet that's always on and runs your website. But if it gets busy because your blog post gets on Hacker News or whatever, you can use the API, spin up some extra droplets. The load balancer will send some of the load there, and then once the Hacker News surge is over, you just destroy those VMs, and you only paid for the couple hours you needed. Plus monitoring and alerting, a 4.9's SLA, and everything else you could need.
Yeah, so it's definitely worth checking out. And remember to use our coupon code FreeBSD Now, and that will give you a $10 credit to get started with your experience on DigitalOcean's cloud. Okay, while we're on the subject of debugging, we have a... Yeah, see, this is the red line through the whole show, I guess. Debugging Emacs, or How I Learned to Stop Worrying and Love DTrace. So this is over at nullprogram.com. And so for some time, Elfeed was experiencing a strange, spurious failure. Every so often, users were seeing an error. Spoiler warning. When updating feeds, error in process, Sentinel, search failed. So if you used Elfeed, you might have even seen this yourself. From the surface, it appeared that curl, tasked with the responsibility for downloading feed data, was producing incomplete output despite reporting a successful run. Since the run was successful, Elfeed assumed certain data wasn't in curl's output buffer, but since it wasn't, it failed hard. Unfortunately, this issue was not reproducible. Manually running curl outside of Emacs never revealed any issues. Asking Elfeed to retry fetching the feeds would work fine. The issue would only randomly rear its head when Elfeed was fetching many feeds in parallel under stress. By the time the error was discovered, the curl process had exited and vital debugging information was lost. Considering that this was likely to be a bug in Emacs itself, there really wasn't a reliable way to capture the necessary debugging information from within the Emacs Lisp. And indeed, this later proved to be the case. So a quick and dirty workaround is to use condition case to catch and swallow the error. Then the bizarre issue shows up rather than fail badly in front of the user, and Elfeed could attempt to swallow the error, assuming it would be reliably detected, of course, and treat the fetch as simply as failure. That didn't sit comfortably with the blog author here. Elfeed had done its due diligence checking for errors already. Someone was lying to Elfeed, and he intended to catch them with their pants on fire. Someday. So he just needed to witness the bug in one of his machines, and Elfeed is part of his daily routine, so surely he had the experience to issue that myself or himself someday. The plan was, should that day come, to run a modified Elfeed instrumented to capture extra data. It would have also routinely run Emacs under GDB so that he could inspect the failure more deeply. But for now, he just had to wait to hunt down that zebra. So, if you heard zebras and DTrace and you think, Brian Cantrell. Yes, and that's the good connection here. So over the holidays, he rediscovered Brian Cantrell, a system software engineer who worked for Sun between 1996 and 2010, and is mostly well known for DTrace, of course. So his first exposure to him was in a BSD Now interview in 2015. I don't know, Alan, do you know that show? I'm not sure.
I've never heard of that one before.
It's epic by now. Okay, so he watched that and decided there was a lot more that he had to learn from him. So he became a personal hero of him and not just of him. So he scoured the internet for more of his writings and talks, which are plenty. Oh, actually, we should want to list one of. He had a list of talks he gave, and we should list
we'll
that.
include a link at the end of the show notes for this article. Brian Cantrell just posted on his DTrace blog a link to most of the talks he's ever given, and he even, possibly because of the BSD Now Trilogy, broke them all up into trilogies on different topics.
Yeah. So for people who can't get enough, they have one source to go now. Okay, so some interesting operating system technology came out of Sun during its final 15 or so years, most notably DTrace and ZFS, as we all know, and Brian speaks about it passionately. Almost as a matter of luck, most of it survived the Oracle acquisition thanks to Sun in releasing it as open source in just the nick of time. Otherwise, it would have been lost forever. The scattered ex-Sun employees still passionate about their prior work at Sun, along with some of their old customers, have since picked up the pieces and kept going on as a community under the name Elomos. It's like an open source flotilla. Oh yeah. So naturally, he wanted to get his hands on this stuff to try it out for himself. Is it really as good as they say? Normally, he would stick to Linux, but generally doesn't see these Sun technologies available. The main reason is license incompatibility, and Sun released its code under the CDDL, which we covered earlier in the show, which is incompatible with the GPL. Ubuntu does infamously include ZFS, but other distributions are unwilling to take that risk. And porting DTrace is a serious undertaking since it's got its fingers throughout the kernel, which also makes the licensing issues even more complicated. And of course, Linux has
interesting that this was posted less than a month before Oracle announces that they're going to integrate DTrace into the mainline Linux kernel.
It's a bit prophetic, yeah. Mm-hmm. Okay, so Linux has a reputation for not invented here syndrome, and these licensing issues certainly contribute to that. Rather than adopt ZFS and DTrace, they've been reinventing from scratch. ButterFS instead of ZFS, and a slew of partial options instead of DTrace itself. Normally, he's mostly interested in system call tracing, and his go is strace, though it certainly has its limitations, including the situation of debugging curl under Emacs. Another famous example of the non-invented here syndrome is Linux's EPOL, which is the broken version of BSD KQ, and that's also been covered in the Trilogy. So he writes, if you want to try out these for yourself, you'll need to install a different operating system. So he's dabbled with OmniOS a little bit, an OS built on Elomos in virtual machines, using it as an alien environment to test some of his software. OmniOS has a philosophy called keep your software to yourself, or KUSTI, which is really just code for we don't do packaging. Honestly, you can't blame them since they're a tiny community. The best solution is to do probably package source, which is essentially a universal package system. Otherwise, you're on your own. And so they cover also a little bit about Open Indiana, but getting back to his original problem, so what is DTrace, or how can you use that? He's done all this talking, but hasn't yet described what DTrace really is. So it won't pretend to write the whole tutorial here, but he'll provide enough information for us to follow along. So DTrace is a tracing framework for debugging production systems in real time, both for the kernel and for applications, basically the whole userland. The production systems part means that it's stable and safe. Using DTrace won't put your system at risk of crashing or damaging the data. The real-time part means that it has little impact on performance, which is important. If you run this in production, then the whole debugging symbols you add or the printfs even might slow it down. So you can use DTrace on live active systems with little impact. Both of these core design principles are vital for troubleshooting these really tricky issues that only show up in production. So there are DTrace probes scattered all throughout the system on system calls, scheduler events, networking events, process events, signals, virtual memory events, etc. And using a specialized language called D, which is unrelated to the general purpose programming language D, you can dynamically add behavior to these instrumentation points. Generally, the behavior is to capture information, but it can also manipulate the event being traced. So then it's basically writing these probes, and each probe is fully identified by a for tuple delimited by colons, a provider, module, function, and probe name. And if you have an empty element, that denotes a sort of a wildcard. so like an asterisk. For example, syscall : open : entry is a probe for the beginning, like the entry of the open syscall, and that matches pretty much all system calls entering that probe. And using strace on Linux, which monitors a specific process, DTrace applies to the entire system when active. To run curl under strace from Emacs, he'd had to modify Emacs behavior to do that. And with DTrace, he could instrument every curl process without making a single change to Emacs, and with negligible impact on Emacs itself. That's a big deal. So, when it comes to his original lfeed issue that brought him all this way, FreeBSD is much better poised for debugging the problem. All he had to do is catch it in the act. However, it's been months since that bug report, and it's been really making not yet the connection. So he's just hoping that he could eventually find an interesting problem where he can apply DTrace. And yeah, we have listed the talks from Brian Cantrell here, of course. And yes, certainly this is the thing where also many people discover DTrace for the first time. They have this problem and they cannot kind of figure out which tool to use to fix this, and they pretty much exhausted all the options, and then they discover DTrace and then see, oh, what kind of cool things it can do, and help them to uncover the actual source of their problem by writing these DTrace probes.
So after a while of not being able to get it to happen, they ran FreeBSD on a Raspberry Pi 2, and they wrote out the SD card and played with it a bit. And they've mostly been using Vim, but eventually they built Emacs, cloned their configuration, and fired it up, and gave lfeed a spin. And that's when search failed. Bug strikes again. Not just once, but dozens of times. It's like, ooh, perfect. This low-power platform is the jackpot for this particular bug, triggering it left and right. Given that I've done, now that I've got DTrace at my disposal, it's the perfect place to debug this. Something is lying to lfeed, and DTrace will play the judge. So there are basic three possibilities. Curl is reporting success, but actually truncating the output. Emacs is quietly truncating the output of curl as its input, or Emacs is misinterpreting curl's exit status. So he shows a little DTrace script here that will look at every write syscall that comes from curl and basically print that out, and look at the exit syscall for programs curl and write out the results there.
Yeah.
And then, so the second probe will print out when the program exits. You can also compare this to exactly what is delivered to lfeed when curl exits. So they modified the process sentinel, the callback that handles the subprocess, so that it would print out some debugging as well. So then they found that when the search failed bug occurs, the buffer is completely empty 95% of the time, or truncated at the end of the HTTP headers before the actual content, about 5% of the time. DTrace indicates that curl did its job to the full, so it's Emacs who's the liar. It's not delivering all of curl's data to lfeed. That's pretty annoying. Secondly, curl was line buffered. Each line was a separate independent write call. I was certainly not expecting this, because the C library only does line buffering when the output is a terminal. That's because it's guessing a user might be watching, expecting the output to arrive one line at a time. So he shows some output from DTrace showing each line being printed separately instead of printing as a big buffer or something. So what would make curl think that Emacs is a terminal? And he's like, oh, that's right. This is the same problem I ran into 4 years ago when writing Emacs XUL. By default, Emacs connects to subprocess through a pseudo terminal, a PTY. I called this a mistake in Emacs back then, and I still stand by that claim. The PTY causes weird, annoying problems for little benefit, such as interpreting control characters, subprocesses getting line buffered and being slower, and standard out and standard error getting mixed together, although that's now optional since Emacs version 25. And then there's a bug somewhere in Emacs that causes truncation when PTYs are used heavily in parallel. Just from eyeballing the DTrace log, I knew what to do. dump the PTY and switch to a pipe. This is controlled by the process connection type variable, and fixing it is just a one-line change. Not only did this completely resolve the truncation issue, lfeed is noticeably faster at fetching feeds on all machines, since it's returning data in big blocks through the pipe instead of one line at a time. It's no longer receiving mountains of XML one line at a time, like sucking pudding through a straw. It's now quite zippy even on the underpowered Raspberry Pi 2.
Cool. Excellent.
So, using DTrace to find and solve the problem.
Yeah, so it was nice, and it was good effort to have DTrace on ARM, because that wasn't a small effort. So and sometimes if you limit the problem space, or just the amount of memory or available CPU resources in general, you can uncover some of the problems pretty early. That's probably why the L41 course from George Neville Neal and Robert Watson at Cambridge also use the BeagleBone Black, because that's a small system that can reach the limits relatively quickly, and then you can decide.
Especially since they're doing performance type stuff, they needed something that wasn't a VM. They wanted every student to have the same system, but they didn't want to have every student have to buy and dedicate a big piece of hardware to something, and it made perfect sense.
Yep.
So yeah, I've added the link to the show notes to Brian Cantrell's blog over at dtrace.org, and he's got his trilogies. The first is the Software Values Trilogy, which talks about what kind of values we try to express with software. Then he's got the Debugging Trilogy, which includes debugging under fire, zebras all the way down, and the hurricane's butterfly. The Beloved Trilogy, where he talks about jails and zones, the slab allocator, and ARC, the adaptive replacement cache for ZFS. Those are three of my favorite things too. The Open Source Trilogy, which starts out with the fork where Alumos splits off from OpenSolaris, corporate open source anti-patterns, looking at why some of the things companies do with open source are not the thing they should do. And also Leaping the Chasm from proprietary to open source, talking about some of the adventures that they had at Sun as they tried to open source technologies like DTrace. Then there's the Container Trilogy, talking about containers and running them on bare metal and so on. A whole trilogy on DTrace. And lastly, the Surge Lightning Talk Trilogy, which my favorite is still tail-fml.
Yeah. And I mean, some of these are more technical, some are more social, or how to organize open source or organizations in general.
I think the oral tradition in software was one that really hit home with me, and thinking how we need to do more of that type of stuff. But there's a range of lengths here, like the lightning talks are quite short, and some of the other ones are like a full hour. But it's more control than you could ever need at one time.
Yeah, for a rainy weekend or something. Something for everyone.
There's actually even some other talks that aren't part of the trilogies in here, including like porting KVM to SmartOS, which has a link, sadly not a talk yet, about going beyond KVM to Beehive.
Oh, excellent! Yeah, something to watch list.
Mm-hmm. Well, that the Beehive one isn't a talk; it's a link to their GitHub RFD about.
Oh yeah,
considering using Beehive instead of
KVM.
KVM, yeah. But lots of good talks, definitely worth checking out.
So after our little corporate exposure in the first part, we are now going to our news roundup this week with the OpenBSD Hackathon A2K18. So this is a little preview here with syncookies coming to PF. So that sounds exciting.
Yes, one eagerly anticipated feature is the arrival of TCP syncookies. Read another important tool in your anti-DDoS toolkit as part of PF. So Henning Bauer added the code in a series of commits starting February 6th with some bits of explanations. The first one is syncookies for PF. When syncookies are on, PF will blindly answer each and every syn, which is the first part of creating a TCP connection, with a syncookie synac. So it randomly uses information from the incoming packet to generate a cookie and send it back as part of the synac, I think setting the sequence number or something, so that when the ACK of that is the next part of the three-way handshake comes in, only at that point does the OS have to do any work. So with a traditional stack back in the 90s, what would happen is someone would send a SYN and say, I would like to open a connection to this port. And the OS would be like, okay, and allocate some memory and set up to receive that and use up a bunch of resources. And wait sometimes multiple minutes before realizing the person on the other end has gone away.
Mm-hmm.
Right? So it's kind of like where someone calls and then hangs up immediately.
Yeah.
You pick up the phone, but it had already stopped ringing or there was nothing there or whatever. This could be used in what's called a SYN flood, where you would just send lots of these I would like to open a connection packets, but never actually follow through with the other parts of the three-way handshake, eventually causing the server to use up all of its memory on these half-open connections. So then syncookies were come up with it, which allows you to do send the response, but do it by setting, I think it's a sequence number, I forget exactly what part of the packet, with basically a hash setup so that the response to the next part, so they send the SYN, you send the SYN ACK, and when they send the ACK, it includes enough information for you to recreate the original SYN and set up the connection. So you don't have to actually allocate memory until they actually finish the three-way handshake.
Yeah, that means the other side is interested in making the connection.
Yeah, that they're actually going to follow through. So that's been part of FreeBSD and I think OpenBSD for quite a long time. This is moving it out of the OS into the firewall. In particular, this means that a firewall sitting in front of a bunch of web servers could stop the SYN floods from even going through the firewall and getting to those web servers, where then you would apply syncookies as a solution. So this is actually allowing you to move the syncookies concept to the edge of your network instead of just the edge of each server.
Yeah, that's certainly helpful.
Yeah. So upon receiving the ACK, that is the completion of the three-way handshake, PF will reconstruct the original SYN packet and shove that through the PF test function, where state will be created, and if a rule set permits it, the packet will go through. Then message the freshly created state. We don't actually see the SYN ACK, just the final ACK. Set up the sequence number modulator, call into the existing SYN proxy code, and start the three-way handshake with the backend host. So the backend server doesn't get all the noise of the SYN and then the SYN ACK. Only once it gets the ACK does the whole connection get set up quickly by the firewall. So the web server doesn't allocate or doesn't even know there's any traffic during the SYN attack. And importantly, PF doesn't allocate any resources at all until you've already completed the three-way handshake. So what they have is adding a somewhat basic for now adaptive mode where syncookies get enabled if a certain percentage of the state table is filled with half-open connections. This makes PF firewalls resistant against large SYN flood attacks. So since there's a slight delay and a little bit of extra work involved in doing this, PF can say, let normal SYNs through, and then if all of a sudden my state table is half full and it's going to start being a problem, then it engages this protection and doesn't create the state table entries until someone actually completes the three-way handshake and then does the extra work. In the initial commit, syncookies are off by default until they gain more experience and confidence that they actually work.
Okay. Yeah, but they also write the first release to have this feature will probably be the upcoming OpenBSD 6.3. If they get a number of testing done by random people or many people that are having this issue or are close to the border to protect their firewalls or their networks behind that from these kinds of attacks. So testing is important, and report anything you find back. And of course, more info is likely to emerge soon in the post-hackathon write-ups. We'll cover them in the future episodes, of course. And it's certainly an interesting project, and I hope...
The obvious downside to this approach is because it sends the syncookied synac before it compares against the PF test function to actually see if the state should be allowed.
Mm-hmm.
I wonder if this means that during the syn flood, it will actually use more outbound bandwidth. Whereas if a host was blocked entirely, you wouldn't send back a response at all. Whereas when syncookies is active, a host that is blocked would complete the three-way handshake and then be rejected. It still wouldn't use any memory in the firewall, which might make this worth the trade-off. But it could possibly actually be a second-level DDoS in that you would send you so many sins that you would send a lot of synacs, although there's no amplification effect, so it would take as much bandwidth as you have to do this. But
then it's not worthwhile.
Yeah. I'm not quite familiar with all the internals yet. I will maybe talk to Henning about this in Tokyo and see. I'm guessing he's thought of this because it's a relatively obvious thing. So it'd be interesting to hear what he says about it.
I guess he will give a talk at one of the next BSD conferences about his efforts in bringing this to PF.
He's giving a talk in Tokyo, if I remember correctly, but I don't remember what the title was. I don't know if it was this or something else.
Well, okay. Then at the latest BSDCon or the EuroBSDCon. So
exactly.
We'll watch this. All right. Next up is a story about a Palemoon. So this is a perfect example of how not to approach open source developers and packagers. So here, this is a link on GitHub where they removed from OpenBSD the ports due to licensing issues. And
so somebody from upstream, so Palemoon is a browser, apparently. I'd never heard of it. And they have some weird licensing restrictions. I guess even Firefox has somewhat similar restrictions. But because of the way Palemoon works, in order to call a custom compiled version of it Palemoon, you have to follow some very specific instructions, including not using the system versions of libraries. It actually bundles its own versions, which they apparently might have modified or something, which basically makes the package bigger or whatever. So in the OpenBSD port, the configure command was basically telling, hey, use the system zlib and the system SQLite instead of the bundled versions. And the upstream said, we do not allow system libraries to be used with officially branded packages. So either you need to remove the configure lines and make it use the bundled version, or call disable official branding and call the build something other than Palemoon. Of course, they did it in not a great way, including starting the problem report with, you will revise your mods config located at this path and remove the following. We do not allow blah, blah, blah. And citing part of the Palemoon redistribution license agreement. So pretty off-putting way to start the conversation. But in the end, it's their software and their license, and if you want to use the software, you do have to follow the license. Although
sure,
having a weird license like this does make it more complicated. Most software that's under a somewhat open source license is pretty straightforward to follow the license term. And then sometimes you get ones like this that have it's got to be at least twice the length of the BSD license just for Section 8 of their redistribution agreement.
Okay. Well, yeah, it's also, that's the community part, how you interact with other people, with contributors, with people who want to apply patches or solve problems, and then it's the matter of how you interact between. I mean, as long as the internet has existed, there are people misunderstanding each other because in writing you cannot put too much emotion, or people think too much of that. But it's also the tone of the conversation that matters a lot when you want to attract contributors.
Yep.
Okay, so this was, that dumpster fire.
Yes. Yeah, and there's some links from the other BSDs and how they're dealing with the same issue.
Yeah, pretty much.
I don't see many people using this Palemoon browser going forward.
It's the first time I heard about it at all. So I mean,
Yes.
they're the three big browsers, but smaller ones keep popping up.
Especially because it's called mozconfig and stuff. I'm guessing it's only a somewhat modified Firefox. So I don't know. I don't know anything about it, but
you're also not likely to look into it further after reading this.
exactly. I wasn't going to look at an alternative browser anyway, but this definitely put it off in my mind.
Yep. But speaking of alternatives, we should mention the second sponsor for this week's episode, IX Systems, because they can provide you a great alternative to your regular off-the-shelf hardware and storage server vendor, because they can pretty much give you a server that's tailored towards your need, whether this is a server that's doing mostly virtual machines or doing a huge database load or needs a lot of CPUs. IX Systems are the folks who can tailor-make you that specific system that's solving your problem that you want to solve with that problem, or with that server, actually. So if you're building a server for open source, then give IX Systems a call, and they can give you recommendations, which parts work better with others, or whether you should put more memory or more disks into that system. So these are the people you want to talk to tailor-made your own special server for that specific purpose.
Yep. They build all the hardware for my business because I need to not worry about things. And they take all the worry out of it because they know BSD, they know open source, and they know the hardware. So I just tell them what I need to do, and they're like, this is the hardware you should use, and I buy it, and it works, and I'm happy. And when there's a problem, they're always right there, standing behind the hardware they sold me, and making sure the problems get solved.
Mm-hmm. And for the small business users or even home users, you could check out the FreeNAS Mini or the Mini XL, which gives you a great storage platform for all your backup needs. And they can also be extended a little bit more with up to 48 terabytes of storage. And it's all running OpenZFS, of course, the reliable file system that you want to have for these high reliability and also storage systems that you're eventually going to use in the future, because you can expand that until the limit that we covered earlier in this show.
Yep. Yeah, and unless you're after boiling the oceans, then of course, IX will custom build anything you want. So if you want to boil the ocean, they'll help you.
You provide the money, they provide the system for that.
So next up, we have a blog post from our friend Colin Percival.
Yeah, so
Says,
Colin Percival, for a number of years, he has been put a lot of work into making FreeBSD work well on Amazon's EC2 cloud.
Because that's what he uses for his business. So he says, a couple years ago, Jeff Barr published a blog post with a timeline of EC2 instances as the instance types evolved. I thought at the time that I should write up a timeline of the FreeBSD EC2 platform, but I didn't get around to it. But last week, as I prepared to ask for sponsorship for my work, I decided it was time to sit down and collect together the long history of how the platform has evolved and improved over the years. Normally, I don't edit blog posts after publishing them, with the exception of the occasional typographical correction, but I do plan on keeping this post up to date with future developments. So starting back in August of 2006, which is a long time ago, Amazon EC2 launches. It supports a single version of Ubuntu Linux, and FreeBSD is not available. But December 13th of 2010, Colin managed to get FreeBSD running on the EC2 T1.micro instance, which was the cheapest one.
Mm-hmm.
Later, in March of 2011, Colin managed to get FreeBSD running on the cluster compute instances, which were the bigger hardware. Then in June of 2011, he got FreeBSD 8.2 running on all 64-bit EC2 instance types by marking them as being Windows in order to get access to the Zen HVM virtualization. Unfortunately, this meant that users had to pay a higher Windows hourly price to include the license for Windows that they wouldn't use. But at the time, Zen mostly relied on a modified version of the Linux kernel to work, where they had the para virtualization, and choosing Windows forced Amazon to allocate you on a machine that supported the newer hardware virtualization with Zen. Because you remember back in the early 2000s, there wasn't hardware virtualization features built into the CPU. It all had to be done in software. Moving forward to the beginning of 2012, Colin got FreeBSD 9.0 running on 32-bit EC2 instances via this same defenestration trick, that is, throwing it out the window. But again, you had to pay the Windows price. Then in August of 2012, Colin moved the FreeBSD rc.d scripts, which handled EC2 functionality, like logging the SSH host keys to the console, into the FreeBSD ports tree, so they'd be easier for people to get. And then in October of 2012, he worked the build process for FreeBSD 9.1 release candidate, and later to use the world bits extracted from the release ISOs. Only the kernel is custom built. And then also the default SSH user changed from root to EC2-user. So we've come a long way, as we'll see in a few minutes. You can run stock FreeBSD on Amazon for quite a while now, but in the beginning, it required a custom kernel, and slowly got less and less custom. Then in October of 2012, Amazon launched the M3 family of instances, which supported the hardware virtualization without the need to pay the Windows tax. So suddenly you could run FreeBSD without having to pay a Windows license. And then by November of 2012, FreeBSD was available in the AWS Marketplace. So you didn't have to upload your own AMI anymore. You could just go to the Marketplace, select FreeBSD, and launch it. Then, about a year later, in October of 2013, Colin finished merging kernel patches into the FreeBSD-based system and reworked the AMI builder again, such that FreeBSD 10.0 Alpha 4 and later used bits extracted from the release ISOs for the entire system, both the world and kernel. FreeBSD Update could now be used for updating everything, including the kernel, on EC2. So before, if you wanted to use FreeBSD Update, the problem was that you needed a custom kernel, and if it installed the generic one, your EC2 instance wouldn't boot properly anymore. But after 2013, that was solved. He also added code to EC2 images so that FreeBSD 10 and later AMIs will run FreeBSD Update when they first boot in order to automatically download and install critical updates, so you don't have to constantly rebuild the AMI. It'll just update itself when it boots. And then he also added code so that it would bootstrap the package tool and install packages at boot time using the AWS CLI package. And then he added config-init, which is something like cloud-init, but a nice shell script. Then in 2014, Amazon launches the T2 family of instances, now the most modern family of every type of EC2 instance, including regular, high memory, high CPU, high I/O, and burstable, support HVM, and there's no longer any need for any FreeBSD user to pay for the Windows tax. And then he added code to FreeBSD 10.2 and later to automatically resize the root file system when they first boot. And it means that a larger root disk can be specified at instance launch time, and everything will just work as expected. Then in April 2015, Colin integrated the EC2 build process into the FreeBSD release engineering process, and it became less something that he does, and it became the responsibility of the FreeBSD release engineering team. So now the images are made by the same people that make the ISOs.
Yep, and the other VM images.
Yep. In January of 2016, he enabled the Intel 82599 based first generation EC2 enhanced networking in FreeBSD 11.0 and later. So this is Intel's I think dual port 10 gigabit network card, and it supports basically SRIOV, where you can pass. It's like hardware pass through, but you're only passing through part of the card, not the whole card, like not a whole port, but just a subdivision of it. So you can allow multiple VMs to share a 10 gig NIC out of hardware, but as if it was hardware virtualization, and it speeds up the network a lot. Then in June of 2016, he enabled the new EC2 VGA console functionality in FreeBSD 11 and later, so that the old Zero console still works, but you can get the VGA screenshots of the screen and so on. And then the enhanced networking worked very reliably, and FreeBSD 11 and later, thanks to discovering and working around a bug in Zen. Then in 2016, the summer of 2016, he also improved throughput of Zen's block front device by enabling indirect segment I/O in FreeBSD 10.4 and later. He wrote this functionality originally in July of 2015, but left it disabled by default at first because of a bug in EC2 that caused it to hurt performance instead of actually make it better. But it basically made disk speeds faster in EC2. Then in July of 2016, he fixed a bug in FreeBSD's virtual memory initialization in order to allow it to support more than 128 CPUs. So FreeBSD 11.0 and later support EC2's X1.32x large instance type with 128 CPUs. Then January of last year, he changed the default configuration of FreeBSD 11.1 and later to support EC2's IPv6 networking setup out of the box once you've flipped the necessary switches to enable IPv6 in EC2. And then in May of 2017, in collaboration with Rick Macklem, he made FreeBSD 11.1 and later compatible with Amazon's Elastic File System, which is basically NFS v4 as a service, via a newly added one open own mount option and lots of bug fixes. Then in later in May, he added support for Amazon's new Elastic Network Adapter in FreeBSD. This is a new custom-built bit of hardware that Amazon uses for networking. The vast majority of the work, like porting the driver code, was actually done by SemiHalf with sponsorship from Amazon. So that was Amazon actually contributing to the process of getting this Elastic networking driver in FreeBSD so that FreeBSD would be a first-class citizen on EC2.
Yeah.
And lastly,
cool.
In December, just a couple of months ago, Colin changed the default configuration in FreeBSD 11.2 and later to make use of Amazon's time sync service, or NTP as a service. So if you use the EC2 images of FreeBSD, it automatically syncs with Amazon's NTP service. So that's what's already done. But you might be interested in what's coming up next. The upcoming FreeBSD release 10.2 will support IPv6 enhanced networking for both the old generation and the new, the Amazon Elastic File System, Amazon Time Services, both serial and VGA consoles, and every EC2 instance type, although he's not sure that FreeBSD actually has a driver to make use of the FPGA or GPU hardware on some of the instance types. When an FreeBSD EC2 instance first launches, it uses config.net to perform any desired configuration based on user data scripts. Then, unless config.net is used to change this, resizes its root file system to fit the provided root disk, download and installs any critical updates, sets up the EC2 user with SSH access, and prints the host key to the console so you can verify that you're actually talking to the right machine. If there's something else you think FreeBSD should support or change in the default configuration for Amazon, you should let Colin know.
Yeah, certainly. And if you like what Colin is doing, then you should maybe give him a little bit back. He has a Patreon page to support him, and that is patreon.com/cpercival. And that will certainly go a long way. I mean, some of these things are taking a long time to develop, and there's also, going back and forth with the Amazon engineers to make that work. But Colin put a lot of effort into this, and there's a good way of using that and giving something back to him to say thanks for for the work he put in there.
Whether it's $5 as a FreeBSD EC2 user or $50 as a corporate user, But also, Colin is offering a support plan. So if you're actually a company that's using FreeBSD on Amazon and you need support or custom build anything, you can actually buy the support contract via Patreon and get 10 hours a month of dedicated call-in time.
Cool. All right. Next up is a story about X network transparency. So with the subtitle being X's network transparency has wound up mostly being a failure. There's a blog post over here that we have. So the author of that piece is or was recently reading Mark Domino's entry about X keyboard problems, in which he said in passing, quoting himself, he has been wondering for years if X's vaunted network transparency was as a failure as it seemed. An interesting idea worth trying out, but one that eventually turned out to be more trouble than it was worth. So his first reaction was to bristle because he uses X's network transparency all the way at work and all the time. And he has several programs to make it work very smoothly, and some core portions of it, of that environment actually would be basically impossible without it. So there's a big qualification on his use of X's network transparency, namely that it's essentially all for text. So when he occasionally goes out of his all text environment of X terms and Emacs and so on, it doesn't go as well. X's network transparency was not designed as it will run Xterm well. Originally, it was to be something that would let you run almost everything remotely, providing a full environment. Even apart from the practical issues covered in Daniel Stone's slide presentation, it's clear that it's been years since X could deliver a real first-class environment over the network. You cannot operate with X over the network in the same way that you do locally. Trying to do this is painful and involves many things that either don't work at all or perform so badly that you don't want to use them. So in his view, there are two things that did in general help X's network and transparency. The first is that networks turned out not to be fast enough even for ordinary things that people wanted to do, at least not the way that X used them. The obvious case is web browsers, of course. Once the web moved to lots of images and worse, video, that was pretty much it. Pretty slow, especially with 24-bit color. And it's obviously not impossible to deliver video across the network with good performance, since YouTube and everyone else does it now, but the video is highly encoded in specialized formats and handled in any sort of general send successive images to the display system. So the second is that the communication facilities that X provided were too narrow and limited. This forced people to go outside of them in order to do all sorts of things, starting with audio and moving to things like dbus and other ways of coordinating environments, handling sophisticated configuration systems, modern fonts, and so on. And when people designed these additional communication protocols, the result generally wasn't something that could be used over the network, especially not without a bunch of setup work that you had to do in addition to remote X. Basic X clients that use X properties for everything may be genuinely network transparent, but there are few of those left these days. Not even Xterm is that anymore, at least if you use XFT fonts. XFT fonts are rendered on the client, and so different hosts may have different renderings of the same thing. So what remains of X's network transparency is useful to do, or at least for some of us, but it's only a shadow of what the original design aimed for. He doesn't think that it is a mistake for X11 to specifically design it in, and to the extent that they did, which is less than you might think, and it did help X out pragmatically in the days of X terminals, but it's mostly it. And he continues to think that remote display protocols are useful in general, but he's in an unusual situation, of course. Most people only ever interact with remote machines with either text mode, SSH, or a browser talking to a web server in the remote machine. So the PS here is that the X protocol issues with synchronous requests that Daniel Stone talks about, but they don't help in this situation. But he thinks that even in those edges, sanded off X's network transparency wouldn't be a success. Arguably, X protocol model committed a lesser version of part of the new WS mistake. Mm-hmm. And goes on a little longer, a little while. So because X's network transparency was basically free at the time. That's a separate link to a separate blog entry. So he recently wrote an entry about how X's network transparency has wound up mostly being a failure. That's what we mentioned. But where is this all coming from? So originally, X originated in mid-1980s, and it was explicitly created to be portable across various Unices, especially the BSD-derived ones, because those were at universities, were mostly using that at the time. And in the mid to late 1980s, Unix had very few IPC methods, especially portable ones. In particular, BSD systems did not have shared memory. It was called System V IPC for the obvious reasons. BSD had TCP and Unix sockets. Some System 5 machines had TCP, and you could likely assume that more would get it. And in general, your safest bet was to assume some sort of abstract stream protocol and then allow for switchable concrete backends. Unsurprisingly, this is exactly what X did. The core protocol is defined as a bidirectional stream of bytes over an abstracted channel. And the concrete implementation of $display had always left you specify the transport mechanism as well as allowing your local system to pick the best mechanism of it. So once you decided that your protocol has to run over abstracted streams, it's not that much more work to make it network transparent. So TCP provides streams, of course, after all. X could have refused to make the byte order of the stream clear or require the server and the client to have access to some of the shared files for the fonts, for example, but he doesn't think that either would have been a particularly big win. He's sure that it took some extra effort and care to make X work across TCP from a different machine, but he doesn't think that it took very much to do that. While at the same time, his explanation here is probably a bit historical, and X's initial development seems relatively strongly tied to something having clients in different machines at the display, or than the displays, which is not unreasonable for the era, but it doesn't hurt to get a feature that you want anyway for a low cost. So he believes that it's important here that X was intended to be portable across different Unixes. If you don't care about portability and can get changes made to your Unix, you can do better. Like, for example, you can add some sort of shared memory for processes to process virtual memory transfers. And he's not sure how the 1980s versions of SunView worked, but he believes they were very SunOS dependent. And Wikipedia only says that SunView was partly implemented in the kernel, which is certainly one way to both share memory and speed things up. And of course, the PS here is that sharing memory through mmap and friends was years in the future at this point and required significant changes when it arrived.
Yep.
Yeah, this is certainly an interesting outcome of how these things develop, and sometimes how they weren't adapted or weren't used as they were originally intended.
Yes, one of the most interesting things about Unix is the number of tools that end up not being used for what they were intended for. Like, I'm sure you've used this one called tar, which is was specifically meant for writing archives to tape. I would speculate that less than a very small percentage of all archives created with tar have ever been written to a tape.
Yeah, or cat. People mostly use it for displaying contents of files and not concatenating.
Rather than actually concatenating files together, yeah.
Yep, so...
I think the first time I saw cat being used to concatenate files was actually the FreeBSD installer, when the images used to be, what were they, like 800K? The tarballs were broken up to a specific size that happened to be divisible, so you could fit like 3 files on a 1.4 meg floppy and 6 files on like a other size floppy. It was some common denominator that you could put so many chunks on, no matter what size floppy you had, it would work out efficiently. And then it would just cat them all together and then untar it at the end.
Yeah, so Unix is interesting, and certainly the toolkit it provides can be used in various interesting ways. So, time for our Beastie Bits this week, starting off with the Grace Hopper celebration of 2018 call for participation. So this is an ACM conference. Mm-hmm. Mostly geared towards women in computing or actually celebrating the women in computing and also attracting more people for computer science and related topics. So this one is taking place September 26th to 28th, conveniently after EuroBSDCon in Houston, Texas. And it's the world's largest gathering of women technologists, and the open source track provides an excellent opportunity to share your FreeBSD-related work or other BSD-related work for that. So this year's open source software track will feature hands-on workshops designed to introduce new skills, build confidence, or deepen technical expertise. They're specifically looking for presenters with a range of experience to share from how to get started when you are new to open source, like many of us started out somewhere, to deeper dives into technical topics the audience may not find elsewhere. And for more information, including the list of topics, it can be found at the Grace Hopper website.
Yeah. Even like in the regular FreeBSD conferences, I wouldn't mind seeing a few more talks that sound a little bit more like a BSD Now interview. Like, how did you first get started in BSD? And, people have just said, oh, I worked on this or that, but actually getting more into the story of their first big commit, kind of like the one I did about working on the bootloader. I'd like to see more talks that just go like 0 to commit.
Yeah, or from how you get started with Unix. How did you discover that, and what made you stick?
Yeah, but I think specifically project focus on like how'd you go from being someone that's heard of FreeBSD to actually committing a feature or application or something a little more than necessarily just a doc commit. But not that I'm disparaging doc commits because that's how I started. But showing people how it's actually not that hard to go from docs to source.
Yeah, it's not the last thing you would ever do, and some of these stories are very different, but they also share a common theme of how people scratched their itches and wanted to get something done or contribute something back, and that's what most people have as their first experience. Yeah,
and they also relate back to the VBSDCon talk, how the way that a lot of us got into BSD is not something that's going to happen to someone now. Mm-hmm. I mostly got into BSD because of IRC. Some people still use IRC, but it's not as popular as it was back then. Dag Erling got into FreeBSD because he wanted to build those demo scene presentations in like tiny assembly files and wanted a base OS that wasn't DOS. Probably not going to happen to many people anymore.
Yeah.
But speaking of how to get young people into BSD, the FreeBSD project has applied and has been accepted as part of Google Summer of Code for 2018. And we're looking for additional suggested projects. So if you have an idea you think would be suitable for a student to do during Summer of Code, then you can add it to the wiki or fill out the Google form. If you're a student and you have your own idea, we're very happy to let you work on your idea. Or if you need an idea, we have this wiki and we're looking for more ideas. Please remember that projects should take roughly 10 to 12 weeks of full-time work for a student, including testing, documentation, etc. Although you ideally want to leave a bit of room for them to get familiar with FreeBSD because they probably aren't already. Ideally, you would also volunteer to mentor the project. However, if you're not able to, at least with your idea, it gives people other ideas as well, right? And that's how brainstorming works. By seeing your idea, it might give them a different idea, or your idea might be popular enough that someone else is willing to mentor it. And while we're not able to do every submission, the more projects we have on our list, the more students we attract, and the more we get out of Google Summer of Code.
Yeah, and you never know what comes out of that. It's good for reputation.
At times, I wasn't sure that Google Summer of Code was that valuable. You see a bunch of projects that maybe get started and students fail, or the project never gets finished or whatever. But then I was talking about it a bit, and then I'm sitting in a room at BSD Cam, and every person in the row beside me is a former GSOC student, most of which who've gone on to mentor other students after.
Yeah, that's great.
I guess we didn't actually talk about it this week. We'll talk about it next week. The Lua bootloader project, Google Summer of Code from 2014, got committed this week. And we'll talk more about that next week. But, sometimes it takes a couple of people and a bit of work, but eventually that project turned out to be quite useful.
Yeah, and may be revived or a little bit polished, and then can be committed as
So
part of
if
the
you
code.
know a student who qualifies for Google Summer of Code and would like to get paid for the summer to work on FreeBSD, they can apply here. But more importantly, if you have a good idea for a project that's suitable for someone that's, still a student, but, it's big enough that there's an advantage to the project, but small enough that I should be able to finish it in the summer, we'd love to have more of those ideas.
Yep. So next item is that OpenBSD Foundation has their 2018 fundraising campaign started. And so we have links, of course, in our show notes. And the details of that campaign can be found on the openbsdfoundation.org website. The goal for this year is $300,000. And the total for smaller donations has already taken the OpenBSD community to bronze level sponsorship. Well, that's good to see.
Yes.
So if you're using OpenBSD in any way or just want to contribute something back, remember, it's not just OpenBSD, but also the sister or daughter projects they have, OpenSSH, OpenNTPD, and all the other stuff that the OpenBSD guys are also using. So if you're at least using OpenSSH, then you might as well drop them a couple of bucks so that they continue their efforts.
Yep.
Oh, speaking of OpenSSH, by the way, we're totally connecting all these points together. Yeah, because our favorite author, Michael W. Lucas, has SSH Mastery second edition out finally. So he writes on his blog, short but sweet, for the last week or so, the new edition of SSH Mastery has been leaking out. It's now available by print in Amazon and in ebooks just about everywhere, iTunes, Kobo, bookstores of Michael Lucas himself, of course, and others. And the print version will soon be available through Ingram's distribution as well, including a dust-jacketed hardcover version. Ooh, that's going to be a couple more weeks,
If you want
though.
to look sophisticated, then you get the hardcover version of SSH Mastery second edition.
Yeah, so you can slap people that are still using Telnet with that.
Yeah. Well, it's more, all of us use SSH all the time, but do we use SSH to the full extent of its power? And the answer is no. You really want to check out the book and see all the cool things you could be doing with SSH that you're not.
Yeah.
I remember when we did one of the very first tutorials we did in the very first BSD Now, like it seems like a decade ago now. But I guess it was 5 years ago now, wasn't it, too? It was awful numbers. Anyway, being able to chain SSHs. So I have one command I can type into SSH, and it's going to go from my laptop to my router, which is the only thing that's internet exposed at my house, and then from there to another machine.
Oh, yeah,
the jump host. Super useful when then I needed to access the IPMI interface for a machine at the FreeBSD test cluster. So that means I had to go from my laptop to a machine at home that would have the right authentication to log into the Centex test cluster, then to the test cluster, and then to the host, or actually create a port forward to make it so that on my laptop I could connect a local host on a certain port, and it would connect me to the IPMI on a machine back home in Canada while jumping through my house and the gateway machine at Centex on the way.
Yeah, and he has a bunch of
I wasn't going to figure out how to do that by myself.
Yeah, you need to have an example in the book to read. And he made a lot of updates for, of course, OpenBSD has also not stood still since the last book came out. So there's chapters on certificate authorities, how to manage keys, and also for things like Ansible and other automation software that's piggybacking on SSH functionality. You can limit those SSH keys to only permit certain operations on the other machine. So that's certainly interesting.
Yep.
So yeah, check out the book and send Michael Lucas a good review if you like the book, and that will certainly help other people. And I mean, SSH is pretty much universal in the whole Unix space. You don't have to be a BSD person to know about the SSH functionalities.
Well, look at it this way. If enough of you don't go buy the book, then Michael Lucas is going to come on the podcast and talk about the book.
And you don't want that. Yeah. So by all means.
Yes. Save
all
us.
of us.
Save us from Michael.
Okay. Oh, how will we segue into this next one?
Yes. So, upcoming Asia BSDCon 2018. Registration is now open.
Yes, be there, Tokyo. It's amazing. The conference is good. The preliminary program is up already, or finally, let's say.
Yep. So day one is tutorials and small meetings. So there'll be PF and networking tutorial with OpenBSD from Peter Hanstein, a managing BSD with Ansible, and an introduction to ZFS, both with Benedict Reicheling. I don't know who that is.
This
and
guy.
the FreeBSD Developer Summit, which is invite only, will be in room C. But you can get invited to that if you really need to. And then day two, there will be more training. Massimiliano Stuggi from RIPE will be teaching IPv6 security, which should be interesting. There will also be students from a university in Italy talking about the NetMap framework for NVF applications, and a continued FreeBSD Developer Summit, and BeehiveCon.
Yeah, that's a whole different or separate thing, but nevertheless also interesting for people interested not only in Beehive, but virtual machines in general and containers and isolation. That's been organized by Michael Dexter and myself a little bit. More Dexter at this point, but I'll help him as much as I can.
Yep. And then on the main day after the opening, which thankfully doesn't start too early, we'll open up with Michael Dexter talking about institutionalizing FreeBSD isolated and virtualized hosts using BSD install, ZFS, and NFS. And concurrent with that will be the design, implementation, and operation of a NetBSD-based system packaging. So packaging based for NetBSD. If you're interested in packaging based on FreeBSD, it might be interesting to find out what they're doing on NetBSD and what we can learn from it. Next up will be tuning FreeBSD for routing and firewalling. Olivier Cochard-Labey will be presenting his latest work on making FreeBSD a better router and firewall. And our friend Sevan Janian will be presenting BSD from scratch, building NetBSD from source with ease, customizing it for your use case or whatever. After lunch, there'll be a plenary session where I hear there might be a panel discussion. Sounds very interesting.
Oh, cool. That's something new.
Yep, exactly. And then after the break, we have building a security appliance based on FreeBSD. Mariusz Zaborski will be sharing some of the insights from Wheel Systems, where they build FreeBSD-based security appliances for SSH monitoring and SSL intercept and a bunch of other interesting things like that. Concurrent with that will be Petr Dudza from SemiHalf talking about porting FreeBSD to IBM's Power 8 platform and Power NV, which is their native virtualization. So this is the new high-end power systems and getting FreeBSD to run on them. So that'll be interesting. Manu, or Emmanuel Vado, will be talking about FreeBSD on ARM32 and ARM64, and basically offering insights on how you could port FreeBSD to a new board. There are so many new boards all the time. Manu could use some help getting FreeBSD running on them all, and so he's going to teach you how to do that. And then Mininet on OpenBSD using R domains for interactive software-defined network testing and development. Sounds quite interesting. And then Colin Percival will present profiling the FreeBSD kernel boot process. Colin's been working on a series of patches, but mostly a set of tools to measure how long it takes FreeBSD to boot and why. The why part is really important. And then former interview guest Sefi will talk about improving the Dragonfly BSD network stack. And that's just the first day. Then we have lots of fun on the second day. Kristaps Johnson will talk about role-based access control in a Beaches web application, which is his framework for building very secure BSD-powered web applications. There will also be talks from a series of students working on Beehive-related things in Romania. The first one will be virtualization on ARM v8. So that's 64-bit ARM Beehive. So that'll be interesting. Then at 10 o'clock, Henning will talk about OpenBSD for X-ray machines and how OpenBSD is used in medical X-ray machines and deals with compliance and all that fun stuff. So that'll be a nice to hear about the applications of OpenBSD in production. Then Mihai Karabas, who's a professor at the university in Romania and will be hosting EuroBSDCon this year, he will talk about implementing a virtual generic interrupt controller for the FreeBSD hypervisor, so extending that into Beehive. Sam Guider will be presenting improving NetDump hardware support and performance with iflib. So that's supporting FreeBSD kernel crash dumps over the network. So last year, Sam presented on how crash dumps work, and one of the things that was missing was NetDump. And this year he's going to talk about how that happens. And then another one of the students from Romania will be talking about FreeBSD VirtIO devices for ARM. So supporting VirtIO on 32-bit ARM and so on. And then we'll have lunch. So all of that before lunch on the second day. Then we have a keynote in the afternoon. Linux rump kernel, yet another virtualization with a librafied kernel. And then in the afternoon, we have Sean Chittenden doing an introduction to FreeBSD VPC and FreeBSD save and restore features for Beehive on AMD CPUs. So this is save and restore is the first step to live migration. It allows you to basically save the memory and state of the machine to a file and resume the machine from that. It also means you could, pause a VM, reboot your machine, and resume the VM. But it's the first step to live migration. So good to see that happening, and support for specifically on AMD CPUs. Now that AMD is going to make a comeback, especially after people have to start replacing CPUs. Then, as traditional, we will have the work in progress session, where we get brief updates from people on what they've been working on, and little bits. They left us a generous 90 minutes for that, because there are lots of little projects that are being worked on, and we'd hope to hear lots of people present, even if you're not a developer at a BSD. I think I presented at my first or second Asia BSD Con of just, hey, what common errors and problems do you run into with ZFS, so that we can build an FAQ in the handbook and answer those questions, or tell people what those common error messages actually mean, or what they're doing wrong. That was a work in progress, so I presented it. You only have to stand up there for 5 minutes. It's like, I think you only get 5 minutes. You can't stay longer if you want. So
they cut you off, yeah.
Yeah.
But it's great to see a lot of new folks there who haven't been before to Asia BSD Con. So that's good to see. Yeah, I'll definitely look forward to that. And if you have the chance to get there, by all means, go. All right, and last but not least, Tarsnap quit support for Bitcoin ending April 1st, and there's also a Chrome bug apparently. So this is a short link on the Tarsnap Announce website. Well, of course, Bitcoin is not going anywhere, so you cannot pay with Bitcoins after April 1st of this year. And the reasons why are detailed in the mail as well. But the other thing is that the second is a far less significant announcement, that some of the Tarsnap users have had problems attempting to pay with credit cards recently, and upon submitting their credit card details, they find themselves presented again with a Tarsnap login form. And this phenomenon is caused by a bug in Chrome's handling of form submissions by out-of-process iframes, and is triggered by enabling the strict site isolation flag in Chrome. So if you run into this problem, you can use a different browser, of course, turn off that option in Chrome specifically, or upgrade to a newer version of Chrome that has a fix in there that was committed on Friday and should be present in future releases as well. Speaking of Tarsnap, actually, that is the third sponsor for our feedback and questions section this week.
So like if you use Chrome, they just fixed Chrome for you or made Google fix it for you. So you should totally check them out.
Yeah, and Tarsnap, of course, is your online backup for the truly paranoid. If you have not yet heard about this, you should definitely, well, everyone should make backups, of course, but Tarsnap makes those backups securely into the cloud and make sure that they are encrypted locally, deduplicated, so there's not much duplicated files in there, so it's smaller than the original size, because you might splatter all your files across a certain file system tree and you can't find the duplicates anymore. Tarsnap takes care of that as well. And once it has created a key and encrypts all your backup, then it uploads it up into the cloud where it's been stored. And as long as you have the key and don't give it away, then you can still retrieve your backup from everywhere where it's stored, because that's on Amazon's cloud, and that's certainly providing enough space for you. And you can start with as little as $5, and if you only have a couple of config files or other keys you want to back up, then it doesn't cost you that much. And there are various clients available for the Unix systems of this world, the Linuxes, the BSDs, macOS also, and Windows. So there's no excuse to not use Tarsnap or not make backups in this cloudified version of a backup. All right, heading back into our feedback and questions section, we have gotten a couple of feedbacks. Keep them going. The first one this week is Todd. He has a couple of questions. So he writes, "Hi guys, Happy New Year." Well, better late than never. So Happy New Year to you too. So he's hoping that we could answer a few questions that have been bugging him. The first one is ZFS snapshots. So if he snapshots a data set and somehow stores it off the device or on a USB key, in the event the data set is hit with CryptoLocker or similar unniceties, would that allow me to survive such an attack by just installing a new system and restoring the snapshot?
Yes. Although if you keep the snapshot on the system, you could recover just by doing ZFS rollback. And it will just roll back to what the snapshot was. It takes about 1 second, and you're back to normal. Or, well, any changes you've made since you made the snapshot are gone, though. So you probably want to have a process creating snapshots automatically, and then you can just be like, I got hit with CryptoLocker 90 minutes ago, so let's rewind 2 hours and done.
Yeah, I'm not affected anymore. But I lost pretty much the 2 hours of work. But if there's nothing happened in the file system or in that data set in particular, then you didn't lose that much, or nothing at all sometimes. Depends on how live that system is or how much data is written to that since the last backup or since the last snapshot. Okay, second question. Back in the Amiga days, there was a special kernel operation called RAD. In short, it would allow you to reserve a chunk of memory and use it as a recoverable RAM drive that would survive a warm boot. I.e., in the say, he made a script that would take a 128 megs of RAM, protect it, and copy Workbench to it. Would that allow him to run the OS entirely from memory? Is there such a method for OpenBSD or FreeBSD?
The hardware-wise, that's impossible. You can do something like with mdconfig, you can make a swap-backed one. So there's a file that is backing the memory disk and changes you right out to memory, go to memory, it's fast, but then get synced to disk too. But no, I don't think that's going to work that well.
Yeah, although I must say that the operating system in general is run from the RAM of the computer, so there's no specialty here just because it survives a reboot. Because the operating
in general, the RAM isn't supposed to survive a reboot. Maybe it does, but the OS is likely to stomp all over it, and no, I don't think that'll work.
Yeah. But it may be changing in the future when there's more non-volatile memory coming around. So, but that remains to be seen. That I know that about that feature from the Amiga days. Not that I did have one, but I heard people talk about it. And but it's not. It didn't caught on to other systems, or it wasn't such a concept that would be, or that it wasn't seen as to be that interesting enough to adapt it to other systems or architectures. But the idea is generally a good one, and having a way to protect your system between reboots is something that people have been thought about it for pretty much all the computer history.
Basically what ZFS does.
Yeah, sure.
It uses the RAM to buffer your writes and cache the things you're using and make them as fast as possible, while at the same time ensuring that they'll still be there if you reboot.
Yep. Okay, third question. If he has a ZFS NAS, is it possible to create a data set for a workstation and have it boot from the NAS as if it was its own hard drive?
There's a couple of approaches here. As a data set, you can do NFS root or something, but likely what you want to do is create a ZVol and then use iSCSI, and you can actually, if you have a machine with the right kind of network card that can boot iSCSI, it will boot it and attach the disk over the network that way, and then you would format the ZVol with whatever the file system of the OS you're going to use. So if it's going to be a Windows workstation, it would actually be NTFS on a ZVol on ZFS. And that's the best way. Or you can use NFS to share the files directly. And then specifically, you had mentioned a VM as an external host. If you have a virtualizer talking to the NAS, you can either host the VM images over NFS or, again, iSCSI. So iSCSI is probably your best bet there.
Mm.
I've not actually done it, but I definitely did consider doing iSCSI boot for my machine here. But I just stuck a couple of SSDs in it and then mount all my bulk storage over the NAS with Samba.
Yeah, would be interesting to do as an experiment or see how it performs or in general day-to-day use. Okay, we hope to answer that questions. Thanks for the feedback that you provided, and keep experimenting, keep using ZFS. I think that's the best way to walk into the future. Okay, next up is Seth with a Tarsnap question. It's short, but nevertheless important. He writes, I've been using Tarsnap since CrashPlan decided to abandon its users, so since August 2017. He deposited his initial $5 and set his backup to run, and then promptly forgot about it. Today, he writes, he added his next $5 to the account 5 months later. He uses it to back up all of his business production data offsite, so in case his office ever burns down, he'll be covered. And he writes, Tarsnap is the best bang for the buck that I have been able to find, so thank you for promoting them. Happy New Year's. Oh yeah, these are all from the beginning of the year to all of the BSD Now team. Yeah, see? Sometimes when people listen to us...
Just make sure you have a copy of the Tarsnap key, not at the office in case it burns down.
Yeah, which we don't hope it ever happened, but
but
just in case.
You want to have the key so you can decrypt the backup, because Tarsnap is actually secure. There's no way they can help you. Unlike some backup companies are like, oh, if you do this and that, and two-factor auth will reset your password and let you in or something. It's physically impossible with Tarsnap because it's built to be secure.
Yeah, and it's cheap enough.
Don't lose your key.
Yeah. Definitely make a backup copy somewhere and store it somewhere safe. But thanks for that feedback. And I guess Colin Percival from Tarsnap is also happy to hear that. Okay, next is Alex with a pseudo question. Alex asks, or he writes, he recently created a FreeBSD 11.1 droplet on DigitalOcean. He has a root user and a regular user, and added a regular user in the wheel group, as someone should do. When logging in as a regular user, if he runs cat etc group, he sees that his username shows up in the wheel group, but when he tries to run sudo, he gets the error, user is not in a sudoers file. This incident will be reported. What is he doing wrong? There is a file called sudoers.
Right. So the concept of the wheel group is separate from sudo. So as the regular user that is in the wheel group, you can use su, not sudo, just su, to switch to root. That will require root's password, not your password. Sudo was created as an alternative with the idea that if people don't need to know root's password, then we can restrict what they can do. So sudo is a little bit more designed towards the idea of you're only allowed to run these specific commands. And so instead of prompting for root's password, it prompts for your password. So what you want to do is just su, not sudo, enter root's password, and you'll now be root. And then you can do vi sudo, all one word, and edit your sudo config file. One of the examples that's in the file but commented out, you'll see it says %wheel, blah, 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 blah. If you uncomment that line, it will allow everybody in the wheel group to have access to sudo. It's just not the default. But in general, sudo, you configure, say, this user can only run this command rather than just generic full root access. So for full root, you just do su. Sudo is more for the specific things. If you want to know more about sudo, there's lots of documentation, but I also recommend Sudo Mastery from Michael W. Lucas, where he shows you some of the more advanced things you can do. And it's a great way to not make a lot of the common mistakes you can make with sudo as well.
Yep.
But yes, likely you just want to do su rather than sudo, and it will work as you expect.
Right. But if you want to do enable sudo, then you just have to do switch back to root, do vi sudo once you have sudo installed. And there's a comment in there that says over a line, allow members of the wheel group to run sudo, and then it's commented out, but when you comment that in and save that file, then your regular user can do sudo.
Isn't that what I just said?
Right, it's just in my words.
Okay.
And if you want to know more about sudo, check out Sudo Mastery from Michael W. Lucas. It's a great book and opens your eyes to, this is also what I can do with sudo. That's certainly a good book that got me a couple of more ideas how to use sudo more efficiently.
I just said exactly that.
I know. I can't repeat it more often. It's just a good thing. All right. Next up is Thomas is up with the FreeBSD on ARM question. So he writes, he has just gotten a macchiato bin. There's a link to that one. That he wishes to use as a firewall and would love to use it on FreeBSD. And as he believes it is to be superior as network and storage systems. Any idea of where to start looking? Also, ZFS on ARM?
ZFS on ARM 64? Sure. On 32? No. I wouldn't recommend that. For this macchiato bin, I don't know. You'd want to find out what SoC it's based on and see if that's supported. I don't know at all. You'd have to talk to some of the ARM people in FreeBSD and see what they would say. I think it's based on the Marvel Armada, which we have some support for. So you probably would want to start looking at the existing support for the Marvel stuff in FreeBSD, and probably getting the DTS files, the device tree stuff from the Linux version, because it'll be the same, and apply that to FreeBSD so that it can detect all the devices. But I'm guessing you're going to be short, say, a network card driver, which would probably impede your ability to use this as a router a little bit. But
right, yeah. I've never seen this board before, so I need to check this out more. Looks interesting. Okay, last but not least, this week is Albert from the Austria BSD user group. And he writes that, he says hi, that they recently restarted the local BSD user group in Vienna, Austria, which is great. So the meeting just happened. That was yesterday from the day we record this. But while the location is not fixed yet, interested people can be check out their website. They link that into... No. Oh, it's not there.
The next meeting is a month from now.
Oh, yeah. Right. They provide a couple of links for their websites where they can find them. They also are available on Twitter. That's the BSD Stammtisch in Austria. Need to know the exact handle, but it's in the show notes. And the current plan is to have the meetings on every second Tuesday, as Alan said. And we'd be happy to announce these. The more user groups we have in different countries, and especially in a beautiful city like Vienna, that should draw a lot of people to the next meeting. And I also saw that they had the notes from their last meeting written up in English. That's even better, so people who couldn't attend can see what was going on and what was talked about. And
are you looking at the actual email? Because in the version in the show notes, all the links are missing.
Yeah, I know. I just cover it from memory.
Okay. We'll have to fix the show notes so that the links are available.
Yeah. So I'm pondering to visit Austria, and maybe I can connect that with a visit to the BSD user group, but that's still far off in the future. And hopefully the user group takes off, gets a little bit more members, and they get regular meetings and interesting discussions.
Despite what you might have heard about BSD dying or something, the user groups are popping up all over the damn place. So probably not dying.
Yeah, not anytime soon. I mean, just the stuff we covered in this episode is enough reason that it's not any BSD at all. Okay, but that's it for this week's episode. Send us anything you find, comments, questions, show notes, ideas, or stuff you found on the internet that is interesting. Send it to feedback@bsdnow.tv, and we'll cover it in a future episode.